Okie dokie here. So 5.4 is all about solving, meaning we need to get to x equals. Okay, so I've got a bunch of examples here. We're just going to work through them, talk about extraneous solutions and such, and then we will be on our way. So number one says solve. Okay, you have to first of all isolate the radical. That's number one. We've got this 2 in front, so we need to divide by 2, divide by 2. So now we're left with the square root of x plus 2 is equal to 4. Okay, the thing that undoes a square root is when you square it. So we squared, and now we're left with x plus 2 is equal to 16. Now we subtract 2, we're left with x equals 14, okay? And then once you're done, look to make sure it's extraneous, people. I don't want you losing points over silly stuff like that, okay? So let's just plug it back in. We've got 2 times the square root of 14 plus 2, which is 2 times the square root of 16, which is 2 times 4, which does equal 8. Perfect. Boom. Done. Good. Okie dokie, anyway. Now we've got the next one, which is this. And this one's a little bit more tricky because the radical's already by itself. Okay, so we can square it, and then we square this side as well. So here on the left, we've got 2x plus 7 is equal to, but here, this is like doing x minus 4 times x minus 4. Please do not write x squared minus 16 and be done with it, okay, because that's not right. All right, here on the left, we can keep it just like this, but this is going to turn into x squared minus 8x plus 16, okay? And then, because we have a quadratic, we need to move it all to one side. So I'm going to move the 2x over and the 7 over. So now I'm left with 0 equals x squared. We subtracted 2x. So now we're left with negative 10x. We subtracted 7. So now we are left with a plus 9. And now we have to solve that quadratic. And because you're so very smart, you remember how to do this. This one actually factors to be x minus 9, x minus 1. And from there, you can say that x is equal to 9 and x is equal to 1. But before you circle those, go back and make sure they're not extraneous. So let's do 9 first. We've got the square root of 2 times x, which is 18, plus 7, which is supposed to be equal to 9 minus 4, which is 5. Okay, that's the square root of 25. Remember, we're talking principal square roots. 5 does equal 5, so we're good. We can circle. Let's do the same thing to 1 now. 2 times 1 is 2, so we've got the square root of 2 plus 7 is equal to 1 minus 4 is negative 3. Well, right away you should see a problem because there's no possible way that if you square root something, we can definitively say that it's negative. So you've got the square root of 9 is equal to negative 3, and 3 is not equal to negative 3. Okay, so this is what we called extraneous. Okay? Sweet. Moving on. Oh boy, this one's fun. Solve that. Okay, so remember how I told you that you had to isolate the radical? Yeah, well, this one's a problem because if you subtract this 1 on the outside here and move it over there, then you really haven't isolated a radical necessarily, okay? Because then you just like moved it over to another radical, and that doesn't help us, okay? So what we're going to actually want to do is try to get rid of some of these square roots. And the way that we get rid of square roots is that we square things just like this, okay? Just like that. And so when we square this, okay, if you square that, you're just left with x plus 2, okay? You can FOIL out all that you want. I'm just going to tell you when you square that section of it, it's x plus 2, okay? Then you're going to have plus 1 square root of x plus 2 plus 1 times the square root of x plus 2 plus 1 on the end, okay, is equal to, and then when you square that, you're just left with 3 minus x. Okay, so now what we got to do is combine these like terms. So we've got x plus 2 plus 2 times the square root of x plus 2 plus 1 is equal to 3 minus x. And it looks really messy, but look, we can combine. There's a 2 and a 1. So now we've got x plus 2 times the square root of x plus 2 plus 3 is equal to 3 minus x. And what's really awesome about this now is that there's 3's on both sides. So if you subtract 3 from both sides, then those go away. So that's cool. And then if you minus x from both sides, then you're just left with 2. Square root of x plus 2 is equal to negative 2x. Okay? Let's isolate our radical now. Divide by 2, divide by 2. You are left with the square root of x plus 2 is equal to negative x. Okay? Now our radical is isolated. So we square both sides. Square both sides. Let's move it up here. When you square that side, you're left with x plus 2. And when you square this side, you're left with x squared. And now we're at a point where we need to get everything on one side. So we subtract x and subtract 2 from both sides. We're left with 0 is equal to x squared minus x minus 2. This factors. Oh, yes, it does. So now we're left with x minus 2 times x minus 1, which then gives you that x is equal to 2 and x is equal to 1. But before you circle it, go back and plug it in to make sure that it's okay. All right, let's plug in 2. Here we've got the square root of 2 plus 1 should equal to the square root of 3 minus 2. 2 plus 2 here, that's the square root of 4 plus 1, which is 2 plus 1, which is 3. Square root of 3 minus 2 is the square root of 1, which is 1. 3 does not equal 1, so this right here, that's extraneous. Okay? Plug in the other one. Usually if one is extraneous, the other is going to be fine, but let's just do it. Also, oh, watch it. That should have been a plus 1. My bad, so that has to be negative. Okay, anyway, sorry, my bad. Plug it in. We've got the square root of negative 1 plus 2 plus 1 should be equal to the square root of 3 minus negative is just like a plus, so let's do that. So now I've got square root of 1 plus 1 should be equal to the square root of 4. The square root of 1 is 1 plus 1 is equal to 2. 2 is equal to 2, so we are good to go. Negative 1 is the answer. Yeehaw, that worked out nicely. Lots of work, but also lots of points on the test, so that's nice, right? Okay, moving on. Number 4, solve. 3x to the power of 3 over 4 minus 2 is equal to 25. Okay, the first thing we have to do is try to get x by itself. We've got this minus 2 on the end. We have to start getting things away from the x. Let's get rid of those. So now we're left with 3x to the 3/4 is equal to 27. Now from here you could do a couple different things. The book will teach you one way. I'm going to teach you the other way. Okay, so I'm going to rewrite this basically as a radical. My 4th is going to come out here, and then we're left with 3x cubed equal to 27. Now you could look at this as 4th rooting 3x first, or you could look at it as cubing it. Okay, the reason I'm going to look at this cube here is because I can see that 27 is a cube of something. So to undo this cube, I can cube root, right? And the reason why that's really handy is when you cube root, that goes away. So on this side, you're left with the 4th root of 3x is equal to, well, the cube root of 27 is 3. Well, that looks prettier, doesn't it? Yeah, it does. Okay. And then to undo a 4th root, you raise it to the power of 4. Just like that. So now we're left with 3x is equal to 3 to the 4th is 81. And then we can divide by 3, so x is equal to 9. Look at that. That's nice. Oh, wait, that's a total lie because 81 divided by 3 is 27. I'm sorry, I got really excited. Okay, I'm just going to tell you it's not extraneous. You can just take my word for it. Okay, again, you can do it like the way we did in class with multiplying by the reciprocal, or that's how the book teaches it too. So I find this way to be easier, but you do you. Okay? All right, a couple more here. So here, we want to solve that. Okay? Whenever you see rational exponents, I would just rewrite them as radicals. Okay, so you've got x plus 12. 1/2 is like the square root. Okay, and the reason why I would do this is because now you can see that the radical is isolated. You can square it to get rid of that radical. So now you're left with x plus 12 is equal to x squared. Okay, so that worked out really nicely. And then you can move everything to one side so that it's x squared minus x minus 12, just like that. That factors to be x minus 4, x plus 3. Okay, so then x is equal to 4 or x is equal to negative 3. Just to save time, you guys, you can plug them back in, all right? I'm going to tell you that the negative 3 is extraneous and the 4 is good to go, okay? All right, last one here. This is now an inequality, but the really awesome news is that you don't really need to know a whole lot of other things. So we have to isolate the x. Plus 4 plus 4. You've got 3 root x has to be less than or equal to 12. Divide by 3, divide by 3. So now you've got the square root of x is less than or equal to 4. To undo a square root, you have to square it. Square it, so x has to be less than or equal to 16, okay? But that's only part of your answer because when you have an even root like that, you have to remember that you cannot even root odd, or sorry, not odd. You cannot even root negative numbers. So you always have to bound below. When you've got an even index like that, you have to bound below by 0 and then bound above by whatever that you ended up with, okay? Or you bound above by 0. You'll understand. There has to be, if there's an even index out there, 2, 4, 6, 8, okay, you've got to bound below by that 0, okay? Hopefully that helped. I know that this chapter's starting to get a little bit rough for some of y'all, but I believe in you. Keep practicing. Keep coming to see me for extra help. See you later.